Welcome to qnawire.
So the current in a diode can be described in this particular equation, the diode equation, given as I equals to I naught times exponential E delta V divided by kBt minus 1. So we want to find out from the initial conditions what is our I naught. This is a constant. Given that our I, the current, is 200 milliamp, I'll just keep it as milliamp. When our properties such as the delta V, the potential difference, is 100 millivolts. So this 100 millivolts, and the temperature is 300 kelvins. So first we want to evaluate this this exponent over here. This exponent is 1.6 times 10 power minus 19 coulombs, 100 millivolts divided by the Boltzmann's constant, and 300 kelvins. So this is about 3.86. Right, so we can actually evaluate what is I naught, taking 200 milliamps divided by e to the power of 3.86 minus 1. So this is about 4.28 milliamps. So this is our I naught. Using this I naught, we can find what is the current when we reverse the potential difference, right? So the potential difference now is negative 100. So the exponent actually doesn't change, right? It just adds a negative sign. So the exponent e to the power e delta v over kBt is now e to the power negative 3.86. Alright, and so the new current, we just take I naught, which is 4.28 milliamps, multiply this by e to the power negative 3.86 minus 1, should give us about negative 4.19 milliamps.